About 30% of the population in Ireland has an allergy to pollen, to fungal spores, but we don't do anything about it here in Ireland, okay? Or we do very, very little. Okay, we don't have a national pollen monitoring network like every other country in Europe, and we certainly don't forecast it like every other country in Europe. You know, if you go on the Met Éireann site, what you'll see is that, you'll see a forecast there, but that's based on work done in the UK and the University of Worcester, and it's not really a forecast at all, it's more of a guess, really, actually, okay? Hopefully we'll change that, okay? So I'm interested in actually just the release of pollen, okay? You can see here, and it's flowing across our city and how it'll interact with, well, the people within that city. What happens if that pollen, they can be quite large, okay? They're maybe 20 to 100 microns, okay? Pollen can be maybe as small as 10 microns, so you probably get maybe 5 pollen across a hair, for instance. And these pollens and these fungus spores, they make up air pollution as well. So when you hear the EPA, people talk about air pollution, things like PM10 and PM2.5, well, these contribute to it as well, okay? And we monitor air pollution, we don't monitor pollen and fungal spores. So the aim of what we try to do is we try to understand how much is released from each tree, each parcel of grass, because if we know the emission from our sources, well, then we know how much is going to be released into the atmosphere. Then if we can understand how it's distributed into the atmosphere, how it's moved across the parcel of air, okay, we can understand where that pollen is going to go. We can understand, well, what part of the country is going to be most affected. And when it's being transported across the country, when it's being transported across the city, like we saw a few seconds ago, it's going to interact with other things. Okay, it's going to interact with air pollution, for instance. That air pollution can attack the surface of it, it can adhere to the surface of it, it can modify the proteins within pollen. Okay, because when we breathe in pollen, it's not the pollen grain itself that gets stuck in our nose that causes the problem. It's the allergen within that pollen grain that seeps out of the pollen, causes our body to overreact. Okay, it's actually almost an autoimmune disease. Our body starts attacking those proteins or going after them, even though those proteins actually won't do anything to our body. Okay, it's an overreaction. But getting back to my original point, that air pollution can modify those proteins, actually make them extra allergenic. Okay, I've mentioned the people who have allergy, but there's another core of people who are very affected by bioaerosols, pollen, fungus spores. It's asthmatics. Ireland has the 4th highest level of asthma in the world. 400,000 asthmatics here in Ireland. And over the lifetime of everybody within the country, that's actually becomes 800,000 people will have asthma at one time or another during their lifetime here in Ireland. And that goes from, an effect where it affects our well-being if it's allergy, but it can be life-threatening if you have asthma. Okay, so if you're not monitoring these particles that can cause these problems, if you're not forecasting when they're going to have high concentrations of them, that cohort of people have no way of mitigating their ability or to mitigate their exposure, for instance. And that could be simple things, Masks are a fantastic way of stopping pollen getting into your nasal cavity, those allergen leaching out. And wearing a mask isn't as big a deal as it was a few years ago after the COVID epidemic. If you had a good forecast, if you understand when these particles were being released in high concentrations and you knew which you were allergic to, maybe you could take your antihistamine the day before. Okay, if you take your antihistamine the day before, when you do interact with that allergen, okay, the histamine that is produced from that interaction, well, it's nullified. The reason why you want to take it the night before is because, well, antihistamines can make you groggy. So if you're taking it the night before, actually maybe you'll get a better sleep. Maybe you'll be able to get rid of some of that brain waste that Janusz was talking about as well. Okay, and then you won't be affected the next day. If you knew there was going to be a high concentration of an allergen in the atmosphere on a certain day, maybe you could say to your boss, can I work from home? And the way how you would predict or how you would produce a good forecast, not use the one that you might see from the University of Worcester, is, well, if you know when your tree is in full bloom and maybe releasing that pollen, and you have a lot of weather parameters, okay, and for instance, the wind speed and the humidity, and that your tree is in full bloom, well, that you might get a lot of pollen release. Okay, so what we do is I work a lot with Met Éireann, okay, they have all of the weather data that I need. Okay, we go out, we create our phenological models, so we understand at what time of year certain plants will release pollen. Okay, we create a mathematical equation, and we can actually understand when pollen is going to be released. Then, well, we also want to be able to measure it. So if we know when it's going to be released, we also want to know how much has been released. And there's a whole host of different ways you can do it. We're trying to use new real-time methodologies to try and do that. Okay, I just have an example here. It's a new real-time instrument. And in short, it actually uses lasers to detect whether there's a pollen in the air or not. Okay, it just sucks in the ambient air. You can see here, it'll shoot it with a laser and it'll give you a scattering profile. Another one will give you actually a hologram of it. It'll give you the fluorescence and it'll give you the polarity. And these 4 bits of information put together will tell you whether you have a dust particle, or whether you have a pollen, or whether you have a fungal spore. And actually, it can do a lot more than that. It can give you the species of pollen that you see. Some pollen species are allergenic, some don't do anything to you. Pine pollen won't do anything to you. It's very low allergenicity, okay? There are, maybe only 1 in a million people will be affected badly by pine pollen. Birch pollen, on the other hand, affects a lot of people within Ireland. Grass pollen, that's the one we all know, okay? Affects lots of people in Ireland. So using this bit of information, bit of artificial intelligence, machine learning, you can classify those particles, you can count those particles, and then you get a really good time series that you can put into the model for forecasting it into the future. Other people have used actually LiDAR, okay? So while this sucks in the ambient air and all the particles in it, shooting it with lasers, this actually just shoots a laser across the sky. And then the reflection of that and the scattering of that actually allows us to have an understanding of what aerosols are in the atmosphere. And in particular, in this case, bioaerosols, pollen and fungal spores. The traditional methodologies that would have been used, okay, are what are called Hurst-type impactors. And they're as basic an instrument as you can get. Okay, they just suck in the ambient air, again, just like this one here. But instead of using fancy lasers and looking at the fluorescence being given off it, for instance, it just sticks it to a sticky substrate, or basically a sticky tape. You bring that back to the lab, you put a chemical on it that stains the pollen, and you actually count it under the microscope. Okay, and if you're trained to be a pollen counter, as they're called, you're able to differentiate the different pollen species, but you do by eye. And while this will give you your information in milliseconds, it takes 2 weeks for you to get your information by the traditional method. Okay? Once we know the pollen is being released and we can start counting it, well, then we can start what's known as doing dispersion modeling. Okay, and this isn't my work, okay, it's far more advanced than what I'm doing currently, although I will hopefully eventually get to dispersion modeling within Ireland. Okay, you can see here other countries in Europe, they know their emission sites, so they all know where all the trees are within their countries. They know how much pollen should be released. They're doing counting. They know which direction the wind is going. They know, and they're able to simulate where the pollen is going to be dispersed. And the color just indicates the higher concentration being moved around. What else can you notice here? Ireland doesn't have anything. So once we have all that as well, what else we want to do? We want to just try and understand, well, where in Ireland we have different pollen species. And then if we can interact with the public, we can understand how many suffer no allergy. Some have allergy sometimes, if we have certain concentrations. Then if we have really, really high concentrations. So what we want to do, we want to have that model to be able to help us understand what's happening here in Ireland. The UK, they do plenty of monitoring, okay, and they do plenty of modelling, and they can understand when they have high concentrations of pollen. Okay, we have about 380,000, 400,000 asthma sufferers. That asthma costs us about 472 million a year, just within Ireland alone. If you want to talk about allergy within Europe, it costs about 50 to 150 billion in allergy alone. Okay, so if you can mitigate people having to use too much antihistamine, too much steroids, having to go to hospital because they've breathed in too much of these particles, that's going to help cut that down. One person dies every 6 days because of asthma here in Ireland. Okay, and every 4 minutes a person's in an emergency room because of asthma. Now, some of that's just air pollution, okay, the stuff coming out of the back of a car, okay, but some of it's because of pollen and fungal spores. There's a lot of information out there that's showing the synergy between what we class as air pollution and what this is bio air pollution. Okay, when they are in the air at the same time, they affect people more. So what could we do? Do you know, if we did have this project up and running, we could produce an earlier warning system for Ireland. That could be really, really help people for all of the reasons and impacts I just mentioned to you there. We've interviewed lots of people who have asthma, who suffer from allergy, okay? And they've actually lost faith in the forecasts that are out there. And for the very reasons why I've mentioned already, they're not real forecasts. They're just people almost trying to guess what's happening. Okay, talking to the Asthma Society, a lot of employers don't really have a lot of empathy for people who have allergy. If you have allergy, if you have the flu, your employer will say, go home, get over it. If you come into them and say, I am suffering from hay fever really, really badly, they'll say, okay, but you can still do your work, yeah. Fungus spores also, a bioaerosol. I'll talk a little bit less about them, but they cause the famine, okay, and that fungal spore is still here today, still destroying crops, still destroying potatoes. Costs the EU about $1 billion in crop losses every year, okay. These instruments here, while I've mentioned them in terms of pollen, they could be used for fungus spores as well. And if we can monitor them and we can forecast fungus spores, we can help agriculture. Okay, guys, I'm going to leave it there because all the other slides don't relate to any of what I was going to talk to you about today. I got all dressed up to not give the talk that I've been practicing for the last day, Sean. So if you have any questions about allergy or what Ireland should be doing, I'll be happy to answer them. Thank you very much.
What kind of resources would you think you have to install a monitoring system over here? How difficult would it be to install a monitoring type monitoring system in Ireland?
Well, thankfully, actually, what I said, there is no monitoring network at the moment. There is movement towards installing that. So there is actually one of those real-time instruments on top of Med-Éireann here in Glasnevin. So while we don't have a network, we have a sampling site. Okay, so if we get one or two more, we'll start calling it a network. And my previous work would have been to use a rudimentary network within Ireland myself, okay, but that was just me being a maniac and running a monitoring network for 3 or 4 years by myself, well, with the help of my colleagues, which is completely unsustainable. I mean,
what would the long-term impact be for this if Ireland were to reforest itself?
It's a really good question. It very much depends on what trees they plant. I mean, I see there is a push to plant birch. Okay, I would suggest they shouldn't plant as much birch as maybe they want, because it's an allergenic tree. It's going to release lots and lots of pollen, and people are going to be affected by it. There are other ones that are less allergenic, So mixed usage of low allergenic trees is what I would suggest. Yeah.
How far away are we from, say, if we have this model, we will be able to reduce incidence and the associated effects by a certain rate?
Well, actually, the Swiss are probably top of the league when it comes to monitoring and modelling within their own country. They actually have a fully automatic network. Okay, we have one of those instruments on top of Med-Éireann, and they have 18 around their country. Okay, and then they have a very good modelling, dispersion modelling that we showed there. And the reason they were able to get so that instrument's quite expensive. Okay, I'm not going to lie, it's about €150,000, maybe €200,000. But they did a cost-benefit analysis on having these instruments and being able to get that information to the public. They showed that the savings that you would have in medicine, admissions to the hospital, any health-related aspect you want to take of it, was worth it. If they got 1.01% of people to use the information that they were giving out, it would actually pay for the whole network. Okay, so I'm hoping here that we can do the same. Okay, get that information. People do actually use the Med-Éireann website a lot. Like, I mean, even if you look at them on Twitter or X or whatever it's called now, they have about 380,000 followers. Like, it's absolutely gigantic. So if you could get maybe a more functional forecast for them, I think it'll pay for itself almost instantaneously.
That's great. Thank you very much.
No worries. Let's do that.